All right, so this is the Chemistry Unit 5 study guide. So just kind of make sure you're following along with this. You will need your periodic table, and you will also need that polyatomic ion list for this because that is on this test. So before we get started, we're actually going to break down that periodic table real quick and make sure we have all our charges. So I'm going to scroll down here to where I have the periodic table at the bottom. Okay, so on your periodic table, so we really need to pay attention to our valence electrons, and where you can see your valence electrons are things like 8A, 7A, 6A, 5A, 4A, 3A, 2A, and 1A. Okay, so that means my charge for my very right side is going to be 0 because I have 8 valence electrons, so I don't need anything. Okay, 7A is going to have a -1 charge because it's missing 1 electron, so it's going to gain 1. Okay, then I'm going to have a -2 charge and then a -3. And then carbon group is going to be a plus or -4 because it could honestly give up 4 electrons or gain 4 electrons. Then you have group 3A, which is going to be a +3. And we're going to jump across that middle section. And then you're going to deal with a +2 over here and then a +1. Okay, then remember in our transition metals, there are 3 elements that are always going to be the same. That is going to be silver, which is always going to be a +1. And zinc is going to be +2, and then aluminum is +3. So again, you need to make sure you know these because when you actually take the test, we just give you a blank periodic table. Okay, so we're going to go back up to the top, and we'll get started on the definition. So the first part of this review is going to be a little bit tedious because we're going to do a little bit of writing. Okay, so hopefully I'll try to get through this as fast as I can. So when we're dealing with a monatomic cation, okay, so mono means 1. Okay, so this is going to be a single atom with a positive charge. Okay, so remember your cations are going to be positive. Okay, and this is due to losing electrons. When you lose an electron, it makes you more positive. So an example would be something like Na with a plus or Ca with a 2+. Okay, monatomic anion, so again, mono, so this is going to be a single atom with a negative charge. Okay, and the reason why it's going to be a negative charge is because it's gaining an electron, which is going to make it more negative. So your examples would be something like F with a minus charge or O with a -2. Okay, now polyatomic. So again, the key term here is poly, which means many. Okay, that is an ion consisting of, so an ion consisting of 2 or more atoms. Okay, so an example of that could be something like phosphate, so PO4 with a -3, or it could be like ammonium, NH4 with a +1. Okay, that would be in a polyatomic ion. Now, oxidation number is simply the charge of an ion. Okay, so charge amount, so that'd be like something like a +1 or a -2, whatever the charge is. Okay, your transition metals, so that's going to be like that main middle group on your periodic table, that D block. Okay, so these are metals that have more than 1 charge. Okay, so those are metals that have more than 1 charge. Okay, and we use Roman numerals for those. Okay, so that'd be something like Fe with a +3. Okay, so if I were to write that out, that would be considered iron, and I would write 3 in Roman numerals, so III. Okay, and we'll get into more of those here in a second. Now, describe the properties of an ionic compound. Okay, so first of all, this is going to have a high melting point / boiling point. Okay, so the reason why it's going to need a high amount of energy to break that bond since it's so strong. Okay, it's going to be a hard, brittle solid. Okay, and when they're solids, that means they're non-conductors, and so that means that they basically cannot transfer electricity through it. But then once you put them in water, they're soluble, so they're going to be soluble in water. Okay, so most of those are going to be able to dissolve once you put it in water. And then once you dissolve, so once dissolved, okay, so those free ions, okay, float and conduct electricity. and those are going to be called electrolytes. Okay, then lastly, they're going to do is they're going to form a lattice structure. Okay, so lattice structure basically just looks like a repeating structure that just kind of just looks like a pattern. Okay, so now we're going to move on to section 3, where we're going to classify a metal, a non-metal, and a metalloid. Okay, so your metals are going to be on the left side of the staircase. Okay, your non-metals are going to be on the right side. And metalloids are going to be right on that line. So right, well, instead of using the term right, since we just used it. Okay, I'm going to switch that. So we're going to say touching staircase. Except aluminum. Okay, now properties about them. So a metal, you know, that's typically what you think. They're going to be shiny, hard, ductile. So ductile means you can just basically draw them into wires. They're going to be malleable. So malleable means that basically how well you can bend them. They're going to be conductive. So conductive basically means you can transfer electricity through them, and they're going to be solid. Okay, non-metal, they're going to be more of a dull color, so not really shiny, more soft. Okay, they're going to be bad conductors, or so bad conductors, so not very good electricity. Okay, now they can be a solid, liquid, or gas. Okay, and they're going to be non-malleable. So they're not very good at being able to bend. Okay, and then basically metalloids are going to be kind of stuck in the middle. They're kind of stuck in limbo between the two. Okay, so they're going to have some properties of both. Okay, so they do have a metallic shine. Okay, they're brittle. And they're semiconductors. Kind of depending on who it is, they're semiconductors. So they're just kind of stuck right in that middle where they kind of share properties of both. Okay, so examples of a metal would be anything on the left side, so anything you could just pick, so magnesium, calcium, silver. Okay, a non-metal is anything on the right side, so chlorine, oxygen, phosphorus. And then a metalloid would be something that's touching the staircase, would be like silicone, germanium, and then arsenic. Okay, now moving on to the next section. So again, you really need to make sure you're using your periodic table with this. And you are more than welcome to fast forward through any of these parts or rewind, whatever you need to do, if you already feel like you're comfortable in this section. Okay, so cesium, okay, that is going to be abbreviated CS. Okay, its group number, remember your group is the number on top. Okay, so that tells you which group you're in. So that is going to be in group 1/1A. Now your valence electrons is that 1A. So when you see 1A, that means it has one valence electron. And the oxidation basically means the charge. What is the charge? And we just talked about the charge. So the charge for group 1 would be a +1. Now the ion symbol is simply just writing out the element. So CS, the abbreviation, with the charge. So +1. So CS +1. Now ion name, remember when we do our naming, if it's a cation, meaning it's positive, we don't change the name. So this one is just going to be cesium. And is it a cation or anion? So since it has a positive charge, that is going to be a cation. Now, strontium, so SR is going to be strontium. Okay, it's in group 2/2A. Okay, it's going to have 2 valence electrons, which is going to give it a charge of +2. Okay, and then my ion symbol would be SR with a +2. Okay, its name, since it's a cation, means I'm not going to change the name at all. It's going to be simply strontium. And it's going to be a cation. Now, let's do bromine because this is going to be a negative. So Br is bromine. Okay, it's in group 17/7A. That means it has 7 valence electrons. And now its charge is actually going to be a -1. So the way I remember that is basically, remember the perfect number is 8. So it wants the 8, so it's missing 1. So that's why it's -1. Now its ion symbol is going to be Br with a -1. Okay. Now, if it's an anion, that's when we change the name. It's no longer bromine, it's now bromide. So remember, if it's an anion, we change the ending to IDE, and that is going to be an anion. Okay, so hopefully you kind of get the gist of this section, so I'm gonna move on to the next. Now, complete the following table using periodic table. Okay, so our groups are the groups that go up and down. Okay, so 1A, 2A, 3A, all that stuff. And then periods are the numbers on the left. Periods are the horizontal rows, basically. Okay, now, if you need to remember, go back and look at noble gas electron configuration. So remember, noble gases are that last group, that 18/8A on the periodic table. Okay, so that's where you would start when we're doing our configuration. So if I were to look up neon and then do 3s2 and then 3p4, that would actually be group 16/6a. Okay, so 3p4 lands on 16/6a, and that is going to be period 3, and your element would be sulfur. Okay, now the next one I have argon, so 4s2, then 3d10, then 4b2. So if you need a refresher on that, so argon, you're going to start at argon and then go down to the next level, go through that first 4s section, and then go through 3d, so that big middle section, and then you're going to go 2 in on the 4p section, and that element is going to be germanium. So I'm just going to write the name of this first, and then we'll figure out the group and period. So the group for germanium is going to be 14/4a, and its period would be 4. Okay, now iodine. So iodine is going to be in group 17/7a, and it's going to be in period 5. Now, if you want to be able to write the noble gas configuration, you're going to have to find the last noble gas before it, which would be krypton. So I'm going to write Kr in in brackets. And then I'm going to go down to the next level, which would bring me to 5s2. And then I'm going to have to go through 4d10. So remember, your D section is always one level behind. And then I'm going back up to 5p, so this would be 5p5. Okay, so again, the key concept here is that a group goes up and down and period goes left to right. Now, coming on to here, so describe the following groups and families. So we're going to talk a little bit about your alkali metals next. I'll try to get through these as quick as I can because this is probably the part that takes the longest, is just simply the writing. Okay, so alkali metals is that very first group. So that is group 1/1a. Okay, that means they have one valence electron. Okay, they are never found alone. Okay, they are very reactive. Okay, that's one of the reasons why they're not found alone. Okay, because they want to bond with someone else. So they're going to try to bond with someone else. And they're so reactive that basically they're explosive. So they're so reactive that if you mix them with water, it becomes violently explosive. So explosive with H2O. Okay, so they're soft. Well, one of your softer metals and easily cut. Okay, and then your reactivity, so basically how well they bond or how much they want to bond, will increase as you go down or with atomic number. Okay, so atomic number. Now, alkaline earth metals are going to be your group 2/2a. Those have 2 valence electrons. Okay, those are also never found alone. Okay, these are going to be a little bit more shiny and harder, so not as easily cut. Okay, and they're going to be a little bit less reactive than group 1. So they're still reactive, but not as reactive as group 1. Okay, then you have your transition metals, so that's that big middle section. Okay, you're mostly your D group, but so basically starting at the D group, going all the way to the staircase. Okay, so these do not follow common characteristics. Okay, that basically means that they're not all like each other. Okay, so they can be very different, and there's not really a way that we can categorize them all in the same kind of group. Okay, besides not knowing their electrons. So their valence electrons, valence electrons can vary. Okay, basically meaning they could be anything. They could be +1, +2, +3, and that's why we use the Roman numerals. Now, halogens is going to be that group 17/7a. Okay, and they have 7 valence electrons. Okay, they are also very reactive. meaning they do want to bond with someone. And so the reason why is because they have 7 valence electrons, and that perfect number is 8. So they're trying to find one more. Okay, and most of those are going to be found in diatomic pairs. Okay, so found in diatomic form, which basically means a pair. So if they are by themselves, they will bond up with another one to be in pairs. And they're going to be mostly in most salts. Now, noble gases, that is your last group, the one on the very far right. Okay, that is going to be your group 18/8A, and they're going to have 8 valence electrons. So that is that octet. Okay, so they've reached that octet. Meaning they're good, so that means they do not react. So they have everything they need. They do not need to bond with anybody, so they're not going to react really with anything. Okay, and they're going to be gases. And most of them are going to be colorless and odorless. Okay, now we're getting to the section. Now we ought to be able to move a little bit faster. So again, you'll need your periodic table for this. So if you need to pause at any moment, okay, if you want to try some of these before I answer it, I would probably try that and see how well you do. Okay, so for section 7, write the ions and chemical formulas for the following ionic compounds. Okay, so ions means I need to write the positive and the negative pieces first before I put them into a formula. Okay, so this is where you're going to use your periodic table. So if you look up calcium on the periodic table, that's in group 2. So that's going to be Ca with a +2 charge. Now chlorine is going to be in that group 7A, which is going to give you Cl with a -1 charge. Now you don't have to put a 1 there. You can put a 1 if you want. Okay, so now I'm basically going to do is I'm going to put those together in a formula. So I need to see, are they balanced? And they are not. I have a +2 and a -1, so that is not balanced. Now you can look at this 2 ways. You can look at it as, okay, I'm trying to get a +2 and a -2. How could I do that? I need to get to the same number. Okay, and you would see that I just basically need 2 chlorines to balance out that 1 calcium. Okay, so you can look at it objectively like that, or you can try the Criss-Cross method, okay, which is where you take the 1 to here, to the calcium, and you're going to take the 2 to the chlorine. So that means I need 1 calcium, so you're just going to write Ca, that means 1. And I'm going to need 2 chlorine, so you're going to write Cl with a 2 on bottom. So that would be your answer right here. So there's your formula, and then your cation would be Ca +2, and chlorine would be a -1. So that would be your answer as well. Okay, now we're going to do B, so potassium phosphide. Okay, so again, if you just see IDE on the end, like all these examples, that means you are simply just dealing with phosphorus. Okay, so it's just going to be phosphorus with a -3 charge. Okay, and potassium is going to be K with a +1 charge. So there's part of your answer right there. And then you could do your crisscross if you want to. So you take the 3 to the potassium and then take the 1, this imaginary 1 right here, to the phosphorus. So that means I need 3 potassiums and 1 phosphorus. So it's really important that you remember that IDE means it's just the element by itself. There is no oxygen, there is no polyatomic ion. Okay, it's just bromine by itself. So like this one would be magnesium, which would be Mg +2. Bromine would be Br with a -1. Okay, I can see those are not balanced. You can do the crisscross, so it would be MgBr2. Okay, so if you're having trouble remembering how I got the charges on there, I would go back to the beginning of the video and check your periodic table and make sure you know how to find those charges. So my next one is going to be sodium fluoride, so this would be Na with a +1, and then fluorine with a -1. Now these numbers already match, so that means I don't have to do crisscross or anything. You just put them together. It would just be NaF. There's your answer. So here's your answer here for your cation anion, and then here is your formula. Strontium oxide, so strontium is going to be Sr with a +2, and then oxygen with a -2. Those are already balanced, so all you got to do is just put them together. So if you did do the crisscross, so just say for this instant you did do the crisscross, and you wrote Sr2 and O2, that would be incorrect because I don't need 2 of each. Okay, so if you can simplify it, go ahead and simplify it. So since both of them share 2, just reduce it. So this would be SRO. Okay, so that would be your correct answer there. Okay, let's move on to, and we'll skip over D. So I feel like that was enough practice for that one. So let's move on to name the following ionic compounds. So first thing I'm going to do is I'm going to see that there are no oxygens involved. Well, there's no polyatomics, and by polyatomic I mean something like this, like NO3 or PO4. Okay, those are those polyatomic lists that you have to know for this test. Okay, and we're going to do some of those examples here in a second. So make sure you know those before we get into this. So if you need to practice those, okay, whatever you got to do, use flashcards, whatever you need to do to basically know those for the quizzes and tests. Now, on section 8, all I'm going to do is name it. Okay, so I'm going to see, so magnesium, so Mg, remember we never changed the first one. We never changed the name of the cation, which is the first one. So Mg would just simply be magnesium. Now, I'm not going to say magnesium chlorine because that just sounds like you picked two elements and you just randomly said them together. Okay, so now if this is a pair or a compound, this becomes magnesium chloride. And again, that IDE means you're just dealing with chlorine by itself. There is no oxygen attached to it, it's just chlorine. Next one, I have Ca, which is going to be calcium, so I'm not going to change that name. And then phosphorus becomes phosphide. Okay, next one I have aluminum and oxygen, so this becomes aluminum oxide. Next one I have is Na, which is going to be sodium, and then F, fluorine becomes fluoride. Okay, so hopefully you kind of get the gist of that. Just don't change the cation name and then just add IDE to the end. Now, number 9 is write the ions and chemical formulas for the following ionic compounds. Now we are dealing with transition metals. So you're seeing that, so you see these Roman numerals right here. That means that you're dealing with a transition metal, so in that D group. Okay, so remember, here's a recap on your Roman numerals. So 1 would be I, 2 would be II, 3 would be III, 4 is going to be IV. The way I remember that is because the I becomes before the V. And then V would be your 5. 6 would be VI. And then 7 would be VII. That's as far as you need to go. Okay, now on your periodic table, so remember, if it was one of those three, your silver, so Ag, okay, zinc, and aluminum. So silver has a charge of +1, zinc has a charge of +2, and aluminum has a charge of +3. Now, if it is one of those three, even though it's in the transition metal group, okay, it does not need a Roman numeral because it's always going to be the same. So you do not need a Roman numeral for those three. Now, manganese, VII oxide. 1, pay attention to manganese. That is not magnesium. Okay, so manganese is actually Mn, and this VII means I have a +7 charge. Now, I'm going to look up oxide. That is just oxygen by itself, and that's going to be a -2 charge. So there's my first part. Those are my ions. Now, one thing I do want to talk about is the Roman numerals. That does not tell me how many manganeses I have. It just tells me the charge of 1 manganese. Okay, so what you can do is you can do your crisscross if you want to. That means I need 2 manganese, and I'm going to need 7 oxygens. Okay, so that means here's my cation, here's my anion, and then here's my formula. Okay, B, copper 2 chloride. So copper is Cu, and that II means a +2 charge, and then chloride would just be chlorine by itself with a -1 charge. Okay, I'm not balanced, so you can do your crisscross. So this becomes CuCl2. So those are your answers right there. Okay, titanium 3 phosphide. So titanium is Ti, and that 3 is going to be a +3 charge. Phosphorus is going to be P with a -3. Now those numbers already match, so all I got to do is just put them together. So that becomes TiP. D, iron 3 sulfide. So iron is Fe, and that 3 means a +3 charge. Sulfur is a -2 charge, so that's S with a -2. I can see those are not balanced, so I'm going to crisscross. So that means I need 2 irons, and I need 3 sulfurs. So those are your answers there. So I feel that we can move on to the next section now. Now, name the following ionic compounds. So when you start seeing transition metals, okay, you can no longer just say manganese sulfide, okay, because you need to tell me what is the charge of that manganese. The way we do that is we have to break it up into ions first. Okay, one of the ways you can do that is by doing the reverse crisscross. Okay, so let me clear this up real quick. So what I'm going to do is I'm going to take the 7 up to the manganese, so that would give it a +7 charge. And I would take the 2 up to the sulfur, and that would give me a -2 charge. Now, before I can commit to the answer, I need to make sure this is correct and make sure it's not a reduced formula. I would see you always check your anion. So always check your anion. because your anions never change their charge. Sulfur is always going to have a -2 charge. So I would need to see if I carry that 2 up there, does it make sense? Does sulfur have a -2 charge? You would look on the periodic table. Yes, it does. So that means this reverse crisscross method works. So that means manganese has a charge of 7. So you're going to write manganese, and then you're going to put 7 in Roman numerals. So that's going to be VII. And then sulfur becomes sulfide. Okay, we'll do the next one. So I have CuF2. So you can try the reverse crisscross. You can take the 2 up to the copper. And then right now, if you do not see a number, that means there's a little imaginary 1 there on copper. So I'm going to take that 1 up here to the fluorine, which would be a -1. And I would see, does fluorine have a -1 charge on the periodic table? It does, so that means this works. So that means copper does have a charge of 2, so this is going to be copper 2, so II, fluoride. Okay, let's do the next one. So Fe2O3. Okay, so I'm going to take this 2 up to the oxygen and see if it works. So oxygen has a charge of -2. You look on the periodic table, it does, so that means this works. So I'm going to take this 3 up to the top of iron. So that means iron has a charge of +3. So you're going to write out iron 3 oxide. Okay, D, I have Zn3P2, so I'm going to take this 3 up to the phosphorus, which gives it a -3. Now I would look, does phosphorus have a charge of -3 on the periodic table? Yes, it does. So that means I can take this 2 up here to zinc, which realistically we should have known this already because zinc is always going to be a +2 charge. You have that on your periodic table. That's what we wrote down at the very beginning of the video. So zinc, now this is important. I'm not going to write zinc 2 phosphide because zinc is always a +2. So I don't need a Roman numeral for those 3. So remember, you don't need a Roman numeral for silver, zinc, or aluminum. Okay, so I can just write zinc phosphide. And there's your answer right there. Okay, E is PbCl4. So I'm going to do my crisscross. So I'm going to take this imaginary 1 on the Pb and take it up to chlorine. So chlorine would be a -1. And see, does that match on the periodic table? Yes, it does. So that means I can take this 4 up here to lead. So that would be a +4. And so this would be lead 4. So IV chloride. Okay, so hopefully that kind of helps here a little bit. I can jump down here to nickel and oxygen real quick, because I just want to make sure. This is where you got to be careful on the reverse crisscross, because if you see, it's in the little imaginary 1s. So if I took the 1 up to the oxygen and there was a -1 charge, I would look on the periodic table, but I would see on the periodic table, oxygen actually has a charge of -2. So this is where you kind of have to be careful. So if oxygen has a charge of -2 and only have 1 of them, and I have 1 nickel to balance that out, that means nickel has to have a charge of +2 to be considered balanced out. So this would be nickel 2 oxide. Okay. Now, jumping down to 11, so write the ions and chemical formulas for the following compounds. So again, this section will be extremely difficult for you if you do not know those polyatomic ions. Okay, so sodium chromate. Okay, sodium you can just find on the periodic table would be Na with a +1. And chromate is going to be CrO4 with a -2. So again, you have to know those, otherwise you're just going to be taking a shot in the dark. Now, I can still do the crisscross method, so you can take the 2 to the Na, meaning I need 2 sodiums. And you can take this 1 from sodium to the chromate, meaning I only need 1, so I'm just going to write CrO4, because that is 1 chromate. So there's your answer right there. Now, barium nitrate, so barium is going to be Ba with a +2, and nitrate is NO3 with a -1. Okay, so if you have trouble remembering a lot of your 8s, there was my video towards a few videos back is how to memorize the polyatomic ions, so you may want to check that out if you need a little help with memorizing some of the 8s. Okay, so now I'm going to take a look at this. I'm going to see, is this balanced? I have a +2 charge and a -1 charge, so it is not balanced. So you can do the crisscross method. You just have to be careful when you're dealing with polyatomics. So if I took this 2 to the NO3 and I took this 1 to the Ba, I do not want to write it like this. I do not want to write Ba and then put NO3 and then put a 2 next to that. Because now it just looks like nitrogen, 1 nitrogen with 32 oxygens. So do not write it that way. If I want 2 nitrates, I'm going to put the whole thing in parentheses first. So I do not alter those polyatomics at all. And then I can just put a 2 outside that. So that would be your correct answer there. Ammonium sulfate is my next one. So ammonium is actually NH4 with a +1 charge. Sulfate is going to be SO4 with a -2. So I can see right now that those are not balanced. So I'm going to take that 2 from the sulfate to the ammonium, meaning I need 2 of them. So if I need 2 ammoniums, I'm going to put ammonium in parentheses first. I'm not going to touch it. And then I'm going to put a 2 outside that. And then since I have a charge of +1 on ammonium, that means I'm going to take that 1 to sulfate, meaning I only need 1 sulfate, which would be SO4. So there's your answer. Aluminum hydroxide is next. So aluminum would be Al with a +3. Okay, hydroxide is going to be OH with a -1. Okay, I can see that those are not balanced, so I'm going to take this 3 to the hydroxide. I'm going to take this 1 to the aluminum. So I only need 1 aluminum and 3 hydroxide, so that's going to be OH in parentheses with a 3. There's your answer. Okay, so now we're going to move on a little bit. We're going to jump down a little bit because we're going to do a lot of practice here in a second on the table part. Okay, so name the following compounds. So NH4Cl, so NH4 is ammonium. So you're going to write ammonium. And then I'm going to look, it's just chlorine by itself, so that's going to be chloride. This is where you have to be careful, because once you start dealing with ites, ides, this is where I see a lot of confusion. If it is chlorine by itself, it is just simply IDE. That's it. It is not chlorate, because chlorate would be something like ClO3. It is not chlorite, because that would be ClO2. Okay, chloride just means it's just chlorine by itself. Okay, B, potassium. So I have K, it's potassium, and Cr2O7 is dichromate. So this would be potassium dichromate. Okay, and we're going to do a lot more examples on this. So I'm going to kind of skip through this section because we're going to go on to that grid next. So this is what I'm talking about. So if you can get through these pretty solid, then you have a pretty good foot to stand on for this test. Okay, so we're going to be doing, basically we're going to be combining everything we've learned. Okay, so I have a cation and an anion. I'm going to see, is it balanced in this first one? I'm going to say no. So you're going to do the crisscross. So I can take this 5 to the nitrogen and take the 3 to the titanium. So this would be titanium 3, so Ti3, and then N's going to have 5. So that would be my balance formula. Now, when it comes to the chemical name, you just have to be careful. I always see, do I need a Roman numeral before I write this name? Now, titanium is in that transition metal group. It is number 22. So that means I cannot just put titanium nitride. I need to put titanium, and then the charge of titanium is +5. So I'm going to put V. Okay, so titanium 5, and now I can put nitride. Okay, next one, I was given the formula, so I have CaNO3 with a 2. So I need to figure out the cation and anion. So the trick is, if you just want to go to the anion, you can go to the anion for every single one of these first, because anions don't change their charge. Okay, so you're going to get NO3, so we know that is NO3 with a -1 charge, and calcium has a charge of +2. I can just find that on the periodic table. Okay, so now I'm going to write out the name, I'm going to write out calcium. Now I say, is calcium a transition metal? No, it's not. It's in group 2, so I don't need a Roman numeral. And NO3 is simply nitrate. Now, next one, I have nickel 2 carbonate, so nickel 2. So nickel, this 2 means I have a charge of 2. It does not tell me I have 2 nickels. It just tells me I have a charge, so Ni with a +2. And carbonate is on your polyatomic list. That is CO3 with a -2. Those are already balanced, so all I got to do is put them together. So this would just be NiCO3. Okay, the next one, I have AlOH3. So if you look up aluminum on the periodic table, it is Al with a +3 charge always. And OH is hydroxide. That is OH with a -1. Okay, now I'm going to write out my name, aluminum. Now, aluminum is in my transition metal group, but remember, it's one of those 3 that is always the same, so it does not need a Roman numeral. So this is simply aluminum hydroxide. Okay, moving on to the next one, I have Sr2 plus and HCO3 minus. I can see that those are not balanced. So if you want to do your crisscross method, that means I need only one strontium. And I need two of these HCO3. So I'm going to put it in parentheses first. So I'm going to put HCO3 in parentheses. And then I can put a 2 outside of that. Okay, so my name would be strontium. And is strontium a transition metal? No, it's not, so I don't need a Roman numeral. And then HCO3 is actually bicarbonate. The next one, I have H plus 1 and PO3 with a minus 3. Okay, so I can see they're not balanced. So I'm going to take that 3, the negative 3 right here, and I'm going to take it to the hydrogen. So that means I need 3 hydrogens. I'm going to take this 1 on the hydrogen and take it to the this is PO3, so I only need one of them. So that means this is just going to be PO3. So that's my formula. Now I can write my name. So it's going to be hydrogen. Now PO3 is on your list. That is actually phosphite. So PHOSPHITE. So it ends in ITE, so phosphite. Okay, move on to the next. I have NH4,2SO4. So NH4 is actually ammonium. So that is NH4 with a plus 1. That's on your polyatomic list. And SO4 is sulfate. So that's SO4 with a minus 2. Okay, so now my name would simply be ammonium sulfate. Okay, so again, it makes your life so much easier if you know those polyatomic ions. Okay, I'll do a couple more and then we'll move on. So I have MgO. So Mg is magnesium. I can just find that on the periodic table as a plus 2 charge. And oxygen is going to be O with a minus 2 charge. And so that is why it's simply MgO, because they're already balanced. And then magnesium, I'm just going to write out magnesium. Magnesium is not a transition metal, so I do not need a Roman numeral. So this would be magnesium oxide. So again, it ends in IDE if it's just an element by itself, not a polyatomic. Okay, next one I have Al and then C2H3O2 and then a 3. So I know Al is aluminum, so that's going to be Al with a plus 3 charge. And C2H3O2 is actually called acetate. That is on your polyatomic list. That's C2H3O2 with a minus 1 charge. Now, when I write out my name, it's going to simply be aluminum. Aluminum does not need a Roman numeral, and then it's going to be acetate. Okay, last one, I have Ag plus 1 and NO3 with a minus 1. So these are already balanced. All I got to do is just put them together. So this would be AgNO3. I'm sorry, HgNO3. Now, Hg is called mercury, and mercury is a transition metal that we do not know the charge of, but in this case, it is a plus 1, so that means I have to put it in Roman numerals. So I'm just going to put I. So mercury 1, and then NO3 is nitrate. Okay, so hopefully that kind of helps you kind of get the gist of how we're doing that. That's basically all this stuff is this is just practice for doing that. Again, if you can do this, or if you need to go back and look at some of the homework assignments that do the same thing, this will make this test a lot easier. Now, when we start doing oxidation numbers, so we only have a little bit left of this review. Okay, so give the oxidation number for each one. So basically what we're trying to do is we're trying to find the charge of each element. Now, when it's something like an ionic bond, like we just were doing, when you have a metal and a non-metal, it's simple. Usually you just look up on the periodic table and you can find it. Okay, or you can do the reverse crisscross, or you can look at your polyatomic list. But now what happens when we have two things that are on the same side? We need to figure out the charge of each of them. Okay, so we're going to do a few of these. So now the first one's going to be the easiest. Okay, so first of all, I'm going to look is, do I see a charge up here in the top right-hand corner? I do not. So if you don't see anything, that means it's basically a charge of 0. Now, if I only have one element to find the charge of, and I don't see a charge there, that means the oxidation number of chlorine is simply 0. So that means we can do the same thing for this carbon down here at D. So if I don't see anything there, so that basically means a 0. And if there's only one element, that means carbon has an oxidation number of 0. So those are the easiest ones. Now, when we look at part B, it says N2O3. Now, if you look on the periodic table, both of those are considered on the right side of the periodic table. So it's not simply -2 and -3 anymore. Okay, so now what we're going to do is we're going to show you how to do that. Okay, so let me clear that up. Now, the way I do this is my first step is to spread them apart so I can give myself some room. So I have 2 nitrogens and 3 oxygens. And I'm going to look, do I have a charge up in the right-hand corner? No, I do not. So it's basically a 0. So what I'm going to do is I'm going to draw a sum line because I know my charges are going to have to equal out to 0. So I'm going to put equals 0. Now, your first step always after I spread them out and draw my sum line and what I'm setting it equal to is to start with oxygen. Oxygen is always going to be -2. It does not change. Okay, that's just the way it is. So now if I have 3 of them, 3 times -2 would give me -6. So basically I need to see is what -6 equals 0. Well, that should be a +6. Now that's the total that would be for my nitrogen. So since I have 2 nitrogens, I'm going to take that 6 and divide it by 2 since there's 2 of them. That means each nitrogen is going to have a charge of +3. So that would be my answer right there. So nitrogen is going to have a charge of +3 and oxygen is going to have a charge of -2. So there's your answer right there. Okay, so the reason why this differs is because this is a covalent bond now. These are simply just sharing electrons. It's an overlapping of electrons, so it does not apply to the ionic rules like we were just doing. Okay, so we're going to do C next. Okay, I'm going to write it over here so I have a little more room. So I have H2, so I have 2 H's. I have 1 sulfur, and then I have 3 oxygens. Okay, I'm going to draw my sum line. I'm going to see what do I need to equal it to. There is nothing, there is no charge there, so it's basically a 0, so I'm going to set it equal to 0. So my next step is to start with oxygen. Okay, so I'm going to start with a -2. So 3 of them, so that's going to be a -6. Now I have 2 to go to next. I'm going to save this sulfur for last. So anything attached to that sulfur, I'm going to say, anything attached to an oxygen, I'm going to save for last because that's the one that's always changing. So I'm going to go to something I always know is going to be the same, and that's going to be hydrogen. Hydrogen is always in group 1, which always has a charge of +1. Now, since I have 2 of them, 2 times +1 would give me +2. So I need to figure out what goes in the middle. So basically I need to see is 2 plus what -6 equals 0. So if you can figure that out, that would be 2 plus 4 -6 equals 0. Now, I only have 1 sulfur. And if my total charge for sulfur has to be 4, I'm going to take that 4 and divide it by 1, meaning sulfur has a charge of +4. So that's my answer. So hydrogen has a charge of +1, sulfur has a charge of +4, and oxygen has a charge of -2. So there is your answer right there. Okay, let's move on. Let's do E. So I want to find out what is the charge of manganese in MnO2. So I'm going to do the same thing. So I'm going to spread it out. I have 1 manganese and 2 oxygens. I'm going to draw my sum line. Do I see a charge there? No, I don't. So I'm going to set it equal to 0. Okay, so each oxygen has a charge of -2. That is my first step right there. So oxygen, I have 2 of them. So 2 times -2 gives me a -4. Okay, now I'm going to find my manganese. So what is the charge of manganese? So I need to say what -4 equals 0. That would be a +4. And since I only have 1 of them, okay, 4 divided by 1 means that this manganese has a charge of +4. So that is my answer right there. So manganese equals +4. Now you could have looked at that on the periodic table like we've been doing earlier, okay, but that is just another way you could do it. So you could do it either way, it doesn't matter. Now F, I want to make sure I do F because I'm dealing with parentheses, so I'm going to do the same thing. I'm going to write over here because I give myself some more room. Well, actually, I'm going to write right here. So I have 1 zinc. Now, when you see a parentheses, you need to make sure you're cross multiplying into that parentheses. So that means I actually have 2 chlorines and I have 6 oxygens. Okay, so I just made sure to take that 2 and multiply what I had on the inside of the parentheses. Now, I still don't see a charge, so that means I'm going to set it equal to 0. Okay, always start with oxygen. Oxygen has a charge of -2. So 6 times -2 gives me -12. Now I'm going to save that chlorine for last because it's attached to oxygen. So I'm going to move on to my zinc. So zinc always has a charge of +2. And I only have 1 of them. So 1 times +2 gives me a +2. Now I need to figure out what's the gap. So 2 plus what? -12 equals 0. Okay, well, that would be 10, so positive 10. Now, chlorine, if I have 2 of them, so I'm going to take that positive 10 and divide it by 2, meaning each one has a charge of plus 5. So there's my answer. So zinc has a charge of plus 2, chlorine has a charge of plus 5, and oxygen has a charge of minus 2. Okay, so let's do one that has actually a charge to it. So let's look at O right here. So I'm going to find the carbon in C2O4 with a 2 minus. So I'll do the same step. So C2O4, I'm going to spread it out, draw my sum line, and I'm going to figure out what I need to equal it to. Now I can look, I do have a charge right here. So it's no longer blank, which means it's no longer 0. So that means we're going to set it equal to -2. So same steps. I'm going to start with oxygen. So oxygen has a charge of -2. I have 4 of them, so 4 times -2 would be a -8. Now I need to figure out what -8 equals -2. That would be a positive 6. So if I have 2 carbons, right here, I'm going to take that positive 6 and divide it by 2. That means each carbon has a charge of plus 3. So there's my answer right there, is carbon has a charge of plus 3. Okay, so this isn't too bad. It just takes repetition and practice. Okay, so let's move on to the last section, and then we are done. Okay, complete the following questions and use complete sentences. So we're going to try to do this for the most part, but I'm going to kind of make this short and quick. Okay, so remember groups. So I'm going to write this. So groups are going to be your vertical columns, and they are going to share valence electrons. That means they all have the same number of valence electrons, which makes them have common characteristics. Okay, then you have a period. So period are going to be your horizontal rows. Okay, so going from left to right. And then they do not share common characteristics. It's just a horizontal row. That's it. There's nothing that they share in common. So do not share common characteristics. Okay. Now, number 2 is, how did Mendeleev arrange the periodic table? Why is he important? What did he predict? So first, he arranged it by atomic weight. So he simply arranged it by atomic weight. So basically lightest to heaviest. Okay, and then he was also the first to create a useful periodic table. Okay, and then third is, what did he predict? So he predicted future discoveries. So he actually left parts of the periodic table blank because he knew that there was something there. Okay, there was these gaps, and so he actually left those gaps for future discoveries. So he predicted future discoveries and basically left gaps in the periodic table. Now, then Moseley came along, okay, and he improved it. So he arranged it by, arranged by atomic number, which is your number of protons. So since he arranged it that way, now that basically aligned it into groups that shared the same common characteristics. Now, why do elements in the same family generally have the similar properties? So same family means group, so vertical column. That's because they have the same number of valence electrons. Okay, so the same number of outer shell electrons. And 5, last question is, why are the electrons in the outer shell of an atom important? Because that determines our charge, and just like you've noticed, that helps us determine how they bond with another atom. So helps determine bonds with another atom. Okay, so hopefully that kind of helped out a little bit, and so make sure you know how to navigate your periodic table, know your charges, basically your polyatomic ions. Okay, so if you need to go back and look at this or look at any other videos, please do so, and then if you have any questions, please let us know.